Hello students, Devashish again from Dev's Learning Hub. So this is my YouTube channel Dev's Learning Hub, as well as I have the page at Facebook, that is also Dev's Learning Hub. So today we are going to start class 10 trigonometry, and this is the first class on trigonometrical identities. And what are the topics I am going to cover today? The topics will be covered: trigonometrical ratios and relations. So the idea of trigonometry, and then square relations, few of the formulas and evaluation of those formulas, and then few examples. Those are based on today's learning: square relations and trigonometrical ratios, and how to solve the problems easily, because the few of the tips I am going to give, so that it will be helping you to solve the problems related to square relations of trigonometrical ratios. Okay, so let's say first we will cover trigonometrical ratios and their relations, right? So what is trigonometrical ratios? Trigonometry, this is the term, it's a Greek word. Trigon, T-R-I-G-O-N, trigon, and then metry. So trigon means triangle, metry means measurement. So trigon, triangle, metry, measurement. That means this is a measurement of triangle. So by this time, what you know that there are different type of triangles. If there are all the sides are equal in a triangle and all the angles are also 60 degrees, then those are called equilateral triangle. If all the sides are unequal, that is called scalene triangle. If only two sides are equal, in that case, those triangles are called isosceles triangle. So you know separately, but you don't know the relationship between the sides and the angle between them. That is what we are going to learn in trigonometry, the relationship between the sides of triangle and the respective angle. And from there, we'll have the trigonometrical ratios, right? So let's say in this rectangle triangle, where angle A, this is 90 degree, this is B, and this is C. So in this triangle, AB is the perpendicular, AC is the base, and BC is the hypotenuse, right? So if you see in this triangle, AB is perpendicular, AC is base, and this angle, this is called the adjacent angle of hypotenuse. This is the adjacent angle of the hypotenuse. This angle, let's say, it is called theta. So from this triangle, there are 6 trigonometrical ratios: sine, cos, tan, and reciprocal of sine is cosec, reciprocal of cos is sec, and reciprocal of tan is cot, right? So now from this triangle, what you can say, the sine theta equals to perpendicular by hypotenuse. So what you can say, this angle C, right? Sine C equals to sine theta equals to perpendicular, P for perpendicular, and hypotenuse I can say H, right? So let's say I denote perpendicular with P, base with B, and hypotenuse is with H, right? P by H. This is what? Sin C or sin theta. Cos C or cos theta, that is equals to base by hypotenuse, that is B by H. What is tan C or tan theta? Tan C, or that is equals to tan theta, that is equals to actually sin theta by cos theta. So what is sin theta? Sin theta is P by H, cos theta is B by H. So it is P by H, and then denominator is B by H, that is equals to P by B, that means perpendicular by base. So tan C equals to perpendicular by base. Sin theta equals to, and theta, what is this angle theta? Theta is the angle between hypotenuse and base. So if somebody asks you to find it out, this sine alpha. Sine alpha means there this hypotenuse is fixed, but when this perpendicular and base, since these two are perpendiculars, these are very relative position. So if somebody asks you to find out the sine alpha, in that case we will consider this base in this same triangle. We will consider this base as perpendicular, and this perpendicular we will consider as base. So straight away what we can say, sine alpha equals to AC by BC. So AC by BC, that means B by H. So actually this sine alpha is now base by hypotenuse. But what is this alpha? Alpha is actually 90 degree minus theta. That means sine of 90 degree minus theta equals to cos theta. So sine alpha equals to B by H, that is equals to cos theta. And what is this alpha? Alpha is nothing but 90 degree minus theta. So this is what the relationship, sine of 90 minus theta equals to cos theta. So this is one relation, and these are the relations. So sine C, what you can see, that sine theta or sine C equals to perpendicular by hypotenuse, P for perpendiculars, H for hypotenuse. Cos C or cos theta equals to base, B for base and by hypotenuse, H for hypotenuse. And tan C, we have seen that it is perpendicular by base, where the angle theta is the angle between hypotenuse and base. So what you can understood from here, there are two things you have understood. What is trigonometrical ratio sine theta, cos theta, tan theta? These are nothing but the ratios of the sides of a rectangle triangle. Second point is, when you will consider sine, cosine, cos full form is cosine, sine, cosine or tan, when you will find these values, and the angle you will consider, that angle you will consider the angle between hypotenuse and base. So therefore, when we are considering here theta, so we are considering sine theta, this is perpendicular, this is hypotenuse, this is base. So hypotenuse is the fixed position, but the perpendicular and base, these two are relative. This is dependent on the angle. When you are considering theta, you will consider this AB as perpendicular, AC as base. And when you are considering alpha, you will consider this AB as base and AC is the perpendicular. So that is why now we have proven sine of 90 minus theta equals to cos theta, sine theta, cos theta and tan theta, the trigonometrical ratios. Now, apart from this sine theta, cos theta, tan theta, also there is cosec theta, sec theta and cot theta. Cosec theta is equals to, cosec theta is the reciprocal of sine theta. So if sine theta is perpendicular by hypotenuse, cosec theta will be hypotenuse by perpendicular. Cos theta is base by hypotenuse, sec theta is the reciprocal of cos theta. That means 1 by sec theta equals to 1 by cos theta equals to hypotenuse by base, not base by hypotenuse. And cot theta is the reciprocal of tan theta. So cot is reciprocal of tan. That means if tan is perpendicular by base, cot will be base by perpendicular. So cosec theta equals to 1 by sine theta equals to 1 by perpendicular by hypotenuse. That means it will be hypotenuse by perpendicular effectively. What is sec theta? Sec theta equals to 1 by cos theta. That is equals to 1 by base by hypotenuse. That means sec theta equals to hypotenuse by base. What is cot theta? Cot theta equals to 1 by tan theta, that is 1 by perpendicular by base. That means cot theta will be base by perpendicular. Base by perpendicular. So that is what all the trigonometrical ratios, sin theta, cos theta, tan theta, cosec theta equals to 1 by sin theta, sec theta equals to 1 by cos theta, cot theta equals to 1 by tan theta. Right? Now we'll do the square relations. Square relations, what are the square relations? First of all, let me write it down here. And for each of the square relations, we'll prove from this triangle. So first square relations, that is sin square theta plus cos square theta, that is equals to 1. How you can prove that? You can prove that straight away from here. So what is the value of sin theta? The value of sin theta is value of sin theta, that is equals to perpendicular by hypotenuse, value of cos theta, that is equals to, so perpendicular by hypotenuse, that means it is AB by BC, and for cos theta it is base by hypotenuse, that means it is AC by BC. Now let us square it and add up. So sin square theta plus cos square theta, that is equals to this one is AB by BC square plus AC by BC square. Okay, that means what we can write it down? We can write down BC square, and you add up AB square plus AC square. That means according to the Pythagoras theorem, AB square plus AC square, that means these two squares sum up. If you square both perpendicular and base, then and sum up, that is equals to the square of hypotenuse. So AB square plus AC square, that is equals to BC square. So BC square, that is equals to 1. So this one is proven. Sin square theta plus cos square theta equals to 1. This is the very important formula, and you have to remember these formulas in trigonometry to solve any problem, right? This one is very important formula. So there are another formulas. So that is how also you can prove from this triangle. Another formula is sec square theta minus tan square theta, that is equals to 1. So here, based on this particular triangle, sec square theta equals to, cos theta is base by hypotenuse. So sec theta will be hypotenuse by base. So what is the hypotenuse? BC. So BC square by AC square. That is what is sec square theta. What is the value of tan square theta? Tan square theta equals to perpendicular square by base square. That means AB square AB square by AC square. So sec square theta minus tan square theta, that is equals to BC square by AC square minus AB square by AC square. That means AC square, that is the denominator, BC square minus AB square. So BC square, AB square plus AC square equals to BC square. Pythagoras theorem. So therefore BC square, BC square minus AB square. So BC square minus AB square means AC square. So AC square by AC square, that is equals to 1. So we have proven this. We have proven this sec square theta minus tan square theta, that is equals to 1. We have proven this one. Okay. So same thing, cosec square theta minus cos square theta, that is equals to 1. The same way you can prove that. So there are three square formulas we have. Sin square theta plus cos square theta equals to 1. Sin and cos, you remember the formulas, majority formulas, those are relevant with sin cos together, sec and tan together, and cosec and cot together. So sin square theta plus cos square theta equals to 1. Sec square theta minus tan square theta equals to 1. Cosec square theta minus cot square theta equals to 1. These three formulas you need to remember from today's session. Right? So these are the three main formulas, square formulas in trigonometry, right? Sin square theta plus cos square theta equals to 1, sec square theta minus tan square theta equals to 1, cosec square theta minus cot square theta equals to 1. I have already shown you why sin square theta plus cos square theta equals to 1, just evaluating from this triangle. Same thing I have done also for sec square theta minus tan square theta equals to 1. Though what you can do on your own, you can just do it similarly for cosec square theta minus cot square theta equals to 1, whether it is coming, how it is coming, not whether it is coming, how it is coming. Okay. Okay. So let's do few of the examples. I'll do few of the examples, but let's understand the tips I am going to give you. How to solve this kind of problems in trigonometry. First of all, when it is asked to prove from left hand side to right hand side, try to start from the complicated side. The more complicated side you can make it simple, rather than starting from the simple side and making it more complex. It is very true, right? Another thing is that you need to find out, you need to realize formulas you need to remember. Here let's say you need to prove tan square a by sec a plus 1 whole square equals to 1 minus cos a by 1 plus cos a. Now how we will first think how to resolve this problem. So tan square a, tan a and sec a, this is what it is given. But this side it is cos a, right? So what you can do, first of all, you can utilize the sec square a, sec and tan a. What is the formula you have? You have the formula of sec a and tan a. From over there you can start it. Left hand side equals to tan square a by sec a plus 1 whole square. Okay, the formula of what we know, sec square a minus tan square a equals to 1, right? This is the formula already we know, we have proven also, right? Now the tan square a means, in that case tan square a means sec square a minus 1. So what you can write it down in place of tan square a, that is sec square a minus 1 by sec a plus 1 whole square. So what is this sec square a minus 1? This is a square minus b square. Sec square a minus 1 means you can write it down sec a plus 1 plus into sec a minus 1, right? So what you can write down? Sec a plus 1 into sec a minus 1, right? By sec a plus 1 whole square. That means sec a plus 1, sec a plus 1 whole square. Numerator sec a plus 1, this is sec a plus 1 whole square. So sec a minus 1 by sec a plus 1. So now you need to convert this sec a to cos a. So sec a equals to 1 by cos a. So what you can write down? You can write down 1 by cos a minus 1 by 1 by cos a plus 1. So if you resolve this one, what will happen? 1 minus cos a by 1 plus cos a. 1 minus cos A by 1 plus cos A. That is what RHS, right hand side. So what you have learned from here, either start from the complicated side and also try to utilize the formula breaking down. What you can do, you could also do just straight away, lot of people they do tan square and sec A, so straight away break it from tan A to sin square A by cos square A. And here also sec A means 1 by cos A. So that way also you can do that, but it is more easier way to do. So there what will happen, sin square A by cos square A, and here also sec A by sec A plus 1 whole square. If you break down straight away sin A cos A, because this side right side it is cos A, that also you can do sec A plus 1, so 1 by cos A plus 1, so 1 plus cos A by cos A whole square. So what will happen, tan square A, this is sin square A by cos square A, this tan square A, divided by sec A plus 1 whole square. That means 1 plus cos A by cos A whole square. That means it will happen, what will happen, this is cos square A by 1 plus cos A whole square. 1 plus cos A whole square. So cos square A and cos square A, that you can straight away cancel. So this one is cancelled. So sin square A by 1 plus cos A whole square. So sin square A means 1 minus cos square A, because sin square A plus cos square A 1. So that means sin square A equals to 1 minus cos square A. So 1 minus cos square A means 1 plus A square minus B square formula, 1 plus cos A into 1 minus cos A, and then you cancel 1 plus cos A from denominator. So 1 minus cos A by 1 plus cos A. So you can do multiple ways, but you need to find out from where it is easy to start. Let's say this one is the complicated side, this one is the easiest side. If you start from right hand side to prove left hand side, it will be a bit difficult. So one problem you can solve it in multiple ways, but you need to remember all the formulas and you need to think how you can utilize your formula more easily. So the second problem is 1 by sec A plus tan A equals to sec A minus tan A. How to resolve this problem? This side you have sec A plus tan A, this side you have sec A minus tan A. That means there is some relationship between these two, sec A plus tan A and sec A minus tan A. Just apply your sense, and there is no denominator at the right side. So if you start from that, there is one formula, sec square A minus tan square A equals to 1. That means sec A plus tan A into sec A minus tan A equals to 1. Straight away if you can multiply these two, then also it is coming 1. So what you need to do, you start from left hand side, LHS, 1 by sec A plus tan A, that is equals to, you multiply both the numerator and denominator with sec A minus tan A. In that case, what will happen, in the denominator will be sec A plus tan A into sec A minus tan A. That means A plus B into A minus B, A square minus B square. So sec square minus tan square equals to 1. So the denominator will be 1 and the numerator will be sec A plus sec A minus tan A. Right? Very simple. But you need to write down that multiplying both numerator and denominator with sec A minus tan A. So what did I say already? You can look into this problem. So I am multiplying both numerator and denominator with this sec A minus tan A. So denominator is sec square A minus tan square A, that is equals to 1 by the formula. You know this formula. So it is right hand side proof, sec A minus tan A. Right, here simply just I have done the manipulation by multiplying both numerator and denominator with the same thing. Because why I have done so? I have done because sec A plus tan A is in the denominator, and then here you need to prove numerator sec A minus tan A. There is some relation straight away. So more you will practice trigonometry, you have to practice a lot. The more you will practice, more your sense will work. Where you need to start from in which problem. Okay. So I hope you understood the basic concept of the trigonometry itself. So I hope you like this class. So if you have liked this video, please click on the like button. And if you would like to have this kind of video again and again, please subscribe my channel Dev's Learning Hub, and also follow my page in Facebook with the same name, Dev's Learning Hub, where you will find also tips like this particular session. Okay. So thank you very much.